Okay, so students, so just want to continue with the part 2 of what we've been doing, part 2 of Unit 2 analysis. So we'll take a look at that. So this one just proving the congruent triangle. So this one given that three pair of segment congruents. So that means so this one the triangle can be proved by side side side. And here's another one. So it's given that angle B is congruent to angle E, angle C is congruent to angle F, and then the included segments, segment BC is congruent to segment EF. So this one is considered angle psi angle. So again, angle F, segments EF, angle E, so angles psi angle. So this one can be proved by ASA, angle psi angle. And here's another one. So we do have two pair of congruent segments. So AB is congruent to segment DE, and then BC is congruent to segment EF. So angle B is congruent to angle E. So this one could be proved by psi angle psi. Psi angle psi. And here's another one. So the triangles, it's already being proved. So let's see, which of the following need to be true in order to show that triangle XYZ is congruent to triangle DEF? So one thing that we notice, angle X is congruent to angle D, angle Y is congruent to angle E. So what we need to show is that either by proving, okay, so in order to use angle psi, so we need to show that not the included segments, so the excluded segments, so segment XZ or segment YZ is congruent to segment EF, or we can prove that by using segment XZ is congruent to segment DF. So the one that we have for the selection is segment YZ is congruent to segment EF. Okay, so here's another one. So which of the following must be true to prove that triangle ABC is congruent to triangle WXY? By using angle psi. So we do have two pairs of angle congruents already. So segment angle A is congruent to angle W. Angle B is congruent to angle X. So in order to apply that angle psi, we need to use that the excluded segments. So that would be considered segment BZ is congruent to segment XY. As you can see that BZ, XY, they consider corresponding segments. And they're not considered included segments in between angle A, angle B, or angle W, and angle X. So which of the following must be true to prove that triangle ABC is congruent to triangle DEF by using angle psi? So similar. So angle psi, so we do have one pair of angle congruents already, so we need another pair. So angle psi, so then that'd be angle B is congruent to angle E. Again, the way to read through it, so angle psi, angle psi. So we do have 5 different kind of postulates to prove the triangle congruency. So one is psi angle psi, angle, or angle psi. It also can be proved by hypotenuse and lay. So the one that's not appropriate method for proving triangle congruence, then that'll be psi angle. There's no such thing. And which of the following is not an appropriate method for proving triangle congruent? Also angle. We never heard about anything like that for proving congruent triangles. So anytime that you see something strange or weird, so those are the ones that I can eliminate. And which of the following statement will not prove triangle ABC is congruent to triangle DEF? So what we got here looks like we do have segments, angle. So we can prove this one by triangle psi angle psi. Or we can prove by angle psi angle. Or angle psi. So this one thing that we can exclude here is that BC is congruent to EF, because there's no such thing like psi angle. Number 18 in the figure below, angle YZA and angle YZX are right angles, and XYZ, angle AYZ are congruent. Okay, so YZA right here looks like perpendicular, but we don't know, so no assumptions. And then YZX, and then angle XYZ, the one up here. So in order to put in the third conditions, so we need to prove this one by using angle psi angle. So we can say the distance between point A and Z is the same as the distance between X and Z. So this one can be proved by angle psi. Okay, so the distance between point A and Z is the same as the distance between point X and Z. So this triangle, this two triangle here, so we can show the congruency by using angle psi. So here's another one. So one thing that we notice, XZ is 10. And what's the length of ZA? Since we do know that there's two triangles, YZX is the same as YZA. So that means segment ZA is also 10. Similar situation, so XA is 50. So what's the length of ZA? So this one, once you prove the triangle congruent, so that means XZ is the same as ZA, so which is half of the distance of 50. So you can say that point Z is kind of like the midpoint, right in between. So this one is 25. And which of the following best describe the similar figure are not congruent? So similar figure, that the reason why they're not congruent because that they don't have the exact same side length. It could be the exact same interior angles or the corresponding angle, but the side length, they're totally different. So they have the same shape but not the same size. So which term best describes two figures that are the same shape but not the same size? Similar. Okay, similar. So that's the one. Okay, it's like this kind of problem here. So one triangle is smaller, the other one is bigger. They both have the exact same shape, but it's not the same size. So this one can be described by similar. So once you deal with the similar triangle, we can show that the similarity proportional ratios or proportionality statement. So here's what we got. So triangle DEF, it's a dilation of triangle ABC. Dilation, that means you want to make the triangle bigger by a scale factor of 1/3. So that means the triangle ABC is 1/3 of the triangles of DEF. And which of the following proportion verify the triangle ABC and triangle DEF are similar? So one thing that we show that it's the highest, the longest leg, the comparison of the segments. So segment AB versus segment DE. So comparing the shortest, the longest segments of both triangles. So this one is the same ratio as AC over DF. So basically what this one is showing that the longest segment of both triangle has the exact same ratios as the comparison of the shortest leg. Okay, so the longest leg over the longest leg is the same as the ratio of the shortest leg of the smaller triangle with the shortest leg of the right triangle, the bigger right triangle. So B is correct. And then number 20, it's quite similar. You want to come up with the proportionality statements. So since triangle ABC and triangle XYZ are similar, so one thing that we notice, AB over XY, the comparison of the longest leg of both triangles. So this one has the exact same ratios of AC over XZ. So AC looks like the shortest leg of the largest triangle, and then XZ is the shortest leg of the smaller triangle. Proportionality. So the next one is quite similar, so you guys can take a look at that. And what about for the right triangles, similarity of the right triangles? So which of the following indicate that triangle ABC and triangle DEF are similar? This one, you can state that triangle ABC is similar to triangle DEF. Not congruent, not about, not equal, but similar. So this one is missing the little symbol, the triangle symbol here. So here's another one. So in order to show that the following describing the similarity. So this one's a blank, supposed to be a blank. I don't know why it's being like a dash here. So triangle ABC is similar to triangle DEF. And here's another one. So triangles are similar. So anytime they see like a little squiggly line like that, that means it's considered similar. It's a symbol of similarity. So what's the scale factor of triangle XYZ to triangle UVW? So this one is just about the comparison of the segments. So make sure that they have the exact same ratios once you compare the line segment. So the way to compare the line segment is always the shortest leg versus the shortest leg of the other triangle. So 6/12, which is 1/2. A/16 is also 1/2. 10/20, it's also 1/2. So the ratio would be considered either 1/2 or 2. But the thing is that it's a triangle XYZ comparison to triangle UVW. I think there's a little typo with this kind of problem here. If that's a comparison of UVW versus XYZ, because the UVW is bigger size compared to XYZ, then the scale factor would be 2. But now, according to the instruction, it's XYZ to triangle UVW. So the ratio would be considered 1/2 because that's a smaller triangle compared to a bigger triangle. So you need to watch out with the order, the descriptions, and also the instruction with the problem. Got to be a little bit careful with the detail here. So it's supposed to be the ratio of a smaller triangle comparing to the bigger triangle. So the ratio is supposed to be 1/2 for this one. So that's a little typo. So now let's take a look at that. The next one. So triangle ABC versus triangle XYZ. So again, this one, it's a bigger triangle from left to right. Bigger triangle versus the small triangle. Again, so I would say that the typo, it's supposed to be 3. Because that's a larger triangle compared to the smaller triangle. So there's something wrong with the apex instruction, the pretest. So what's the scale factor of triangle XYZ to triangle UVW? Again, the comparison of the segments, 60/6, then that's 10. 90/9, that's 10. 75/7.5, that's also 10. So I would say that it's 10, not 110. I don't know why this one is being flipped with the ratios. It's supposed to be like a comparison of the larger triangle over the smaller triangle. So triangle ABC has been translated 5 units to the right as shown in the figure diagram. In the diagram, what's the length of segment A prime, B prime? So A prime, B prime. So 5 units to the right. Well, translation, it guaranteed that it's the exact same kind of figure, same shape, same size. So A prime, B prime, it's always guaranteed that to be 10. So translation is considered part of the transformation. It's also considered isometry. So that guaranteed that it's the exact same segments, it's the exact same angle. So triangle XYZ has been rotated 90 degrees as shown in the diagram. What's the length of segment Y prime, Z prime? Again, Y prime, Z prime is the same segment as YZ. So it's the same distance, so which is also 7. So the next one is quite similar. So what's the length of segment V prime, B prime? Again, that's considered the same segment of VB. So it's also 5. So the way to prove the triangle similarity, we do have 3 different postulates to do that. One is by angle. The other one is by psi, angle psi. And then the third one, it's by psi. Psi, that means you have to show the exact same ratio of the comparison of those 3 corresponding segments. angle, you need to show that exact same angle with the first and the second pair. And then psi angle psi, you need to show the proportionality of two different segments and then include an angle. Okay, so this one could be proved by angle. So which similarity postulates or theorem can be used to verify that the two triangles shown below are similar? So this one can be proved by psi angle psi. Because 3 over 9, that's 1/3. 5 over 15 is also the same as the same ratio, so 1/3. And 50 is congruent to 50. So this one can be proved by psi angle psi. So this one too, 12 over 4, that's 3, same as the ratios of 6 over 2. 90-degree angles, so they're congruent. So this one could be proved by psi angle psi. And then for 25, so given that the triangles shown below are similar, what is the value of x? So this one you want to use the proportionality. So you can set up the equation as 3 over 15, so that equals x over 25. So 3 over 15, that would give you the ratios of 3. And then, well, 3 over 15, that will give you the ratios of 1/3. So 1/3 times 25, then that will give you 25 over 3. Wait, hold on a second. So 3 over 15, that will give you the ratios of 1/5. And then 25 times 1/5, then that will give you 5. So it's all about the proportionality. So another way that I can set up the equation would be like this way. Okay, so let me just put it right here. So in order to show that, so you can just do that, set up the proportionality. So 25 over 5, which is, okay, going back to the diagram. So 25, well, it's 25 over x equals 15 over 3. So 25 over x. So that equals 15 over 3. Again, it's all about the comparison of the segments. So this one obviously can cross multiply. Or, well, let's just cross multiply it out first. So this one is 15x, so that equals 75. Divided by 15. So we get x equals 5. Another way you can do it, same kind of equations, but you can reduce the number first. So 25 over x, that's 5. And then you multiply by x both sides, so and then divided by 5. So x would be considered 5. So you can do it either way, proportionality. And now let's go back. So here's another one. So find the value of x. So this one you can set up the ratio, so 32 over 16, so it's the same as the ratio, so 48 over x. Comparison of the segments, so the longest leg versus the longest leg, the shortest leg versus the shortest leg. So 32 over 16, that's 2, and then 48 divided by 2, then that will give you 24. So it's all about the proportionality, so this one, the next one is quite similar. So find the value of x. So 20 over 10, which is the same as the ratios of 28 over x. So this one will give you 14, because the scale factor is by 2. So which one of the following statements verify that triangle XYZ is similar to triangles QPR? So this one can be proved by angle. So we don't know about any segment here, but since we do know that the congruent angles, two pairs of congruent angles. So this one can be proved by angle postulate. So this one can be proved by psi angle psi, again showing the same ratios. 18 over 9, which is 2. The other one here, isosceles triangles, 18 over 9. So it's also 2 by the scale factor, so psi angle psi. So which of the following verify the triangles cow is similar to triangle pig? So this one can be proved by psi because that 3 segment, it shows the exact same similarity ratios. So 4 over 12, which is 1/3, 5 over 15, 1/3, 7 over 21, 1/3, by psi theorem. In the triangle below, what's the measure of angle R? So the way to find the missing angle here, so we can use, Well, this one is considered psi angle, so we can use the law of cosine. No, we can use the law of sine, and also at the same time we can use the properties of isosceles triangle. So two segments are equal, so that means the base angle got to be exactly the same. So this one is 30, so that means this angle here is also 30. Corresponding. And this one right here, so isosceles triangles, so the special property, two segments are equal. Same thing happened with that, the base angles, they're considered congruent. So 25 is congruent to 25 for the base angles. And this one too, so angle Z, which is considered 65 degrees. And then angle B, so 28 degrees, isosceles triangle. So in the triangle below, what's the length of MN? So isosceles triangle, so this one is 20, this one is also 20. And this one's 12, it's pretty basic. 14. Okay, so now let's just keep going. And what about the equilateral triangles? So all three sides of a triangle are equal, so that means it's going to be considered an equilateral triangles. So the special feature about the equilateral triangles, so not only those three sides are equal, but also the interior angles, all three interior angles got to be considered congruent. So each angle got to be 60, 60, and 60 degrees. So this one too, 60 degree. And which of the following statement is true concerning triangle ABC below? So angle B is the largest angle. The reason why that is because that angle B is facing to the longest leg. So the corresponding angles, so it's facing to the longest leg. So that guaranteed that's the largest angle. So this one is called the Hinge Theorem. Whatever the longest leg that you have, the opposite angle is always guaranteed the largest. Let's say that if you have the shortest leg of a triangle, the opposite angle would be considered the smallest angle. So here's another one. So which one of the following statement is true concerning triangle ABC below? So 7, it's the shortest segment, So that means angle A is the smallest angle. And which one of the following statement is true concerning triangle XYZ below? So this one we want to find out the longest leg. So the longest leg would be considered the one facing across the largest angle. So the one considered the longest leg would be segment YZ, because this one is facing to angle X. And angle X is the largest angle here. And now keep going. So this one, proportionality. So in the figure, segment PQ is parallel to segment RS. So it's all about the parallel postulates. The length of PQ is 2 centimeters. So PQ is 2 centimeters. And the length of RS is 6 centimeters. So comparison of these two segments, so the ratio will be considered 2/6, which is 1/3. And the length of QT, it's 4 centimeters. And what's the length of TS? So using the ratio proportionality, so RPQ over RS is the same as the ratios of TQ over TS. So the ratio for this one is 1/3. And then in order to find out TS, so we just need to multiply 3 by 4. So we get 12. Again, it's all about the proportionality statement that we set up earlier. So the way you can do it, so it's going to be similar to this one. So what we got here, it's 2/6. So that equals 4/x. We can cross multiply if you want to. So we got 2x equals 24, and then x equals 12. Or we can simply reduce it first before we cross multiplied it. Same thing. Again, it's all about the comparison of the line segments. So we do have two similar triangles here. So TPQ versus triangle TRS. So here's another one. It's quite similar. So you guys can take a look at that. So PT is 3 centimeter. And then PQ is 5. So RS is 15. So you want to find out RT. So comparison, so 5 over 15, so that'll give you 1/3. And then 3 times 3, then you'll get 9. Okay, so now let's move on to something else. So this one showing that the composite figure. So segment EN is congruent to segment NG. So which of the following statement cannot be true? So EN and then NG. So one thing we do notice that P is not the midpoint then. So P is the midpoint, and that will be considered the false statement, which is not true. So here's another one. So TZ is the mid-segment. So TZ is the mid-segments of this triangles. QRS, mid-segments. So that means this one shows the midpoint above of this line segment here. The midpoint of QR, and Z would be the midpoint of QS. So which of the following statement cannot be true? So that means QT, it's not less than TR. Well, this one is showing that it's less than, which is not correct. So again, mid-segment, guarantee that the point here, T is the midpoint of QR, and Z is the midpoint of QS. So segments WX is congruent to segments WZ. Okay, so which of the following statement cannot be true? So S is the midpoint. So this one it's hard to tell. So now the next one, so which of the following best describes segment XW? So this one can say that it's a median. The reason why it's a median, because the bottom base is being cut up into half, 15 and 15. And this one can say that's a median. So anytime that you see the segment cuts off the bottom base into half, so that following segment is considered a median. Here's another one for median. Altitude, that means it's a line segment which is perpendicular from the vertex to the bottom base of the triangle, so it's called the altitude. So here's another altitude. Here's another one. So now 35 in the figure below, which term best describe point X? So anytime that you see that with the 3 median, with the 3 segments median, the point of intersection of 3 segments median. So this one is called a centroid. The reason why that I do know that this segments, all 3 of the segments are the median, because that you see the mark here, double mark, single mark, triple mark. It shows that all the segment cross through, those are the medians. So once you see the point of intersections of all the median, so this point here is called a centroid. So here's another one, centroids. So the point of intersections of those 3 medians of a triangle. Another centroids, so point of intersections of all the median. Now, what about if you see the point of intersections of the perpendicular bisector? The reason why I do know that they're the perpendicular bisector, because it shows the congruent segments for the corresponding base, and also it shows the little square symbol. So that's why all this 3 line segment here, they are considered the perpendicular bisector. So you see the point where they intersect with all the perpendicular bisector. So that point is called the circumcenter. Again, the point of intersections of 3 perpendicular bisector within a triangle, it's called the circumcenter. So here's another circumcenter. So the point of intersections of 3 perpendicular bisectors. Here's another one. Now, what about you see the point of intersections of three altitude? The altitude of a triangles. Here's another altitude of a triangles. Altitude of the triangle depends on which way that you look at the base. So you see the point of intersection of three altitude of a triangles. So this one is called the author center. Again, the point of the intersections of all three altitudes of a triangles, it's called the author center. So here's another one. Okay, so it's all the altitudes. So it's a position where they all meet together with all three altitudes. So it's called the author center. So 38, in the triangle below, which of the following best describes segment AD? So segment AD. So you see that those two angles, they're equal. So that means this one is called the angle bisector. Angle bisector. So here's another one, angle bisector, all angle bisector. So 39 is a little bit different. So this one, let's see what that is. Which of the following statement is true? So the segment BD is perpendicular to segment EC. Okay, obviously that one is not true. The segment BD bisects segment EC. That one is not true either. BD is over here, never bisects EC. And then segment ED is congruent to segment DC. Well, that one doesn't even make sense. And then segment DE bisects segment AC. Well, this one is true because that AD is the same as EC. So we can say that segment DE is just a bisector. It's a segment bisector of segment AC. So here's another one. So point E is the midpoint of a segment AC. Since we do know that this one, those two line segments, they're equal. So 39. So which of the following statement is true? So the segment DE is perpendicular to segment AC. Well, it is, because that shows the little square symbol, so that means it's always perpendicular. So question number 40, which of the following is correct? Name BD below. So you can say that this one, since we do know B is the midpoint of segment AC and D is the midpoint of segment CE, so BD would be considered the midsegments of triangles ACE. So it's the midsegment. So here's another situation with the midsegment. So again, anytime that I see things that's being cut off halfway through, and it's being connected with 2 points. So that line segment, it's considered the midsegment. So which one is the midsegments of triangle ACE? Obviously, it's segment BD. So which of the following is the midsegments of triangles ACE? It's also segment BD or DB. In the diagram of triangle JKL, which term describe point M? So point M here, so you can see that it's the intersections of three perpendicular bisectors, so it's called the circumcenter. Again, the reason why that I do know those are the three perpendicular bisector because that the mark and also the little square symbols shows that they're perpendicular. So the point where they all intersect, it's called the circumcenter. So here's another situation of the circumcenter. So it's the point where they intersect with three perpendicular bisector. So here's another one, circumcenter. So 42, that's a proof. So according to the statement, this one is showing that TR is congruent to OT, and TR plus OT equals QR, and RU is congruent to US. So RU plus US equals RS. So you want to put in the corresponding reasons. So this one I would say that's the definition of a midpoint. Because this one is showing that TR is the same as QT. And then RU is the same as US. So that's why TU is the midsegment. So this one can be proved by the definition of midpoint. So here's another one. So given that the statement, and you want to find out the missing statement. So in order to apply the reflexive property, that means we need to show the exact same angle here, or the exact same segments. So in order to show the triangle similar, we can either prove by side, angle, and then, or angle, angle. So this one has nothing to do with the size anymore because that we showed the proportionality already. So the last thing we need to show is the angle. So it's an overlapping angle here. So angle TRU, which is the same as angle QRS. So angle QRS is the same as angle TRU. So this one is by the reflexive property. So here's another one. So showing that the triangle is similar. So besides showing the triangle similar, another thing you want to show here, it's about the mid-segments. So this one is proof that TU is the line segment, which is the mid-segments of triangles RQS. Okay, so we're almost done with the analysis. 43. So this one, if you see anything that's considered intersections of angle bisectors, the reason why they are considered angle bisector because it shows that the arc showing the congruent angle, double arcs, congruent angles, triple arcs, congruent angle. So the point where they all intersect here, so this one is called the incenter. So the point where that all three angle bisector meet, so that point is called the incenter. So here's another situation with the incenter. Okay, so that's another one. So mid-segments of a triangle, so mid-segment, it's always half of the bottom base of the triangle. So this one, given that AC, the bottom base is 28, so what's the distance of segment LM, the mid-segment? So which is just half of the distance of 28, so it's 14. So segment AC is 30, so how long is LM? Half of 30, so it's 15. So here's another one. So LM, it's 8. The mid-segment is given already. So you want to find out the bottom base of the triangle. So which is twice as long as the mid-segment. So 2 times 18, 16. And then 45, showing that the triangle looks like they're quite similar. Triangle ABC is similar to triangle ECD. So what's the length of AC? Right here, the length of AC. So this one we can set up the proportionality statement once again. So 7 over 21, which is the same ratios as AC over 16. So 7 over 21, then that'll be 1/3. And then 1/3, well, let's see. So it's actually 7 over 21, so that equals x over 12. So 1/3 times 12, then that'll give you 4 miles. So here's another one, so quite similar. So triangle CAB is similar to triangle CED, and then segment AB is parallel to segment ED. So AB is parallel to segment DE, so that means this two angles, they're considered corresponding. So if this one is 50, well, not corresponding, it's called the alternate interior angles. So angle A is 50, so that means angle CED, it's also 50. So here's another situation. So angle A is the same as angle E, alternate interior angles. Because that AB is parallel to segment ED. And I guess that's all for part 2 of Unit 2, the pretest analysis. So thank you for watching the video today. So again, any questions that you have, so please feel free and send me the message, let me know. And also you're more than welcome to watch this video twice or more. Alright, so I'll see you guys next time. Take care.